Imagine a tiny, tenacious messenger flung from Earth, an emissary of human curiosity and hope, carrying with it the dreams of an entire planet. This messenger is not a person, but a machine, a spacecraft built by human hands, designed to survive the harshest conditions of the cosmos. Its mission? To journey farther than any object made by humans had ever gone before, venturing into the unknown, braving the vast emptiness between worlds. On a journey of cosmic proportions, it would travel billions of kilometers, crossing the invisible boundaries that separate the planets, propelled by the ingenuity and ambition of those who sent it. This was not just a voyage through space, but a leap into the future, a testament to our desire to explore, to understand, and to reach out beyond our small blue world. This was NASA's Voyager 2, launched in 1977 for a grand tour of the outer solar system, a rare planetary alignment that comes once every 175 years. The timing was perfect, allowing Voyager 2 to use the gravity of each giant planet as a cosmic slingshot, gaining speed and changing course to visit worlds never before seen up close. It was a mission of unprecedented ambition, designed to unlock the mysteries of the solar system's most distant giants. Voyager 2 became our robotic ambassador, venturing beyond the asteroid belt to reveal the unknown. It sailed past countless rocky fragments, each one a relic of the solar system's earliest days, and pressed onward into the cold, dark reaches where sunlight grows faint, and the planets become mere pinpricks of light. After historic encounters with Jupiter and Saturn, where it captured breathtaking images and made groundbreaking discoveries, it set course for Uranus. This pale blue-green world, shrouded in mystery, is unlike any other planet in our solar system. Uranus is tipped dramatically on its side, spinning almost perpendicular to its orbit, creating seasons that last decades and a climate that defies easy explanation. In January 1986, after nearly 9 years in space, Voyager 2 became the first and only spacecraft to visit Uranus, offering a fleeting 6-hour glimpse. During this brief encounter, it raced past the planet at over 64,000 kilometers per hour, its instruments working tirelessly to capture every possible detail. The data it sent back would transform our understanding of this distant, enigmatic world. The flyby was a triumph, revealing new moons, faint rings, and a world far stranger and quieter than expected. Voyager 2 discovered 10 new moons, mapped the planet's delicate rings, and found that Uranus's atmosphere was colder and more mysterious than anyone had imagined. It also revealed a magnetic field, unlike any other, tilted and offset from the planet's center, adding to the puzzle of Uranus's unique nature. Little did we know, Voyager 2's brief encounter would define our understanding of Uranus for decades, its secrets waiting to be rediscovered. As Voyager 2 sailed onward into the darkness, it left behind a legacy of discovery, a reminder that even a lonely messenger sent from our small world can illuminate the mysteries of the cosmos and inspire generations yet to come. When Voyager 2's data reached Earth, scientists were stunned by contradictions. Uranus had fierce radiation belts, second only to Jupiter, suggesting a dynamic magnetosphere. Yet, the surrounding space was eerily empty, lacking the plasma usually supplied by moons. Unlike Jupiter's Io or Saturn's Enceladus, Uranus's 5 large moons seemed silent. The magnetosphere was a near vacuum, a paradox that baffled researchers. How could such intense radiation exist without the plasma to fuel it? The prevailing theory, Uranus's moons were geologically dead, leaving the system desolate and inert. For nearly 4 decades, this image of a quiet, peculiar Uranus went unchallenged. Science thrives on questioning old assumptions. In 2024, scientists revisited Voyager 2's data with fresh eyes and modern tools. They discovered Voyager 2's flyby coincided with a rare, powerful solar wind event, an extreme space weather storm. The solar wind's pressure was nearly 4 times higher than normal, a storm that happens only about 4% of the time. Our only snapshot of Uranus was during a cosmic hurricane, not a typical day. The data wasn't wrong, but our interpretation was skewed by this fluke. The quiet magnetosphere and dead moons may have been illusions, artifacts of a stormy moment. Uranus, it turns out, might be far more dynamic than we ever imagined. To solve the Uranus mystery, imagine its magnetosphere as a vast, invisible shield, an immense bubble of magnetic energy that wraps around the planet, protecting it from the relentless assault of the solar wind. This shield is not static, it breathes and flexes, expanding and contracting in response to the ever-changing conditions of space weather. Under normal circumstances, Uranus's magnetosphere stretches far into space, forming a protective cocoon, but when a powerful solar storm sweeps through, this shield is suddenly and dramatically squashed, compressed by the force of the incoming solar wind. The boundary of this shield, called the magnetopause, is usually found about 22 Uranus radii from the planet. But during the storm it was forced inward to just 17 radii, a staggering 78% reduction in volume. Imagine the entire protective bubble shrinking almost overnight, leaving the planet's environment exposed and transformed. If Voyager 2 had arrived just a week earlier, it would have encountered a completely different world, a magnetosphere in its normal, expanded state, filled with swirling charged particles and a more typical planetary environment. But the timing was extraordinary. The compression acted like squeezing a sponge, forcing much of the plasma and energetic particles out of the system in a sudden, violent purge. As a result, Voyager 2 found itself passing through an unusually empty magnetosphere, not because Uranus is always so barren, but because the storm had just swept the region clean, leaving behind a ghostly, depleted space. Yet, paradoxically, the same event that cleared out the plasma also energized the particles that remained, supercharging them and creating the intense radiation belts that Voyager detected, belts far more powerful than anyone had expected. This is the heart of the paradox, an environment that was both eerily empty and fiercely radioactive, two sides of the same storm-driven coin. The violence of the solar storm had both swept the magnetosphere clean and left behind a dangerous legacy of energized particles. The mysteries that baffled scientists for decades were, in fact, the result of a single, extraordinary event, a cosmic coincidence of timing and space weather. In the end, it was not the nature of Uranus itself, but the precise moment of Voyager's arrival, that shaped our view and deepened the enigma of this distant, icy world. The solar storm of 1986 finally explains Uranus's empty magnetic bubble. For years, scientists blamed Uranus's odd tilt and magnetic field for its leaky magnetosphere. But the real culprit was timing. The magnetosphere had just been scoured clean by a rare solar wind event. Plasma likely filled the system before and after Voyager 2's visit. The moons weren't silent, their activity was simply hidden by the storm. Uranus is not a static outlier, but a dynamic world, its environment cycling with the sun's whims. The old image of a vacuum magnetosphere is obsolete. Uranus's true nature was masked by a cosmic coincidence. When Voyager 2 swept past Uranus in 1986, its instruments sent back a portrait of a world that seemed frozen in time. The spacecraft's data painted Uranus as a quiet, lifeless system, a cosmic museum of frozen moons, locked in deep cold and silence. The planet itself spun on its side, shrouded in a pale blue haze, while its moons drifted in the darkness, appearing as little more than icy relics from the solar system's distant past. The lack of plasma in the environment suggested that these moons were geologically inert, with no signs of subsurface oceans, geysers, or any internal activity. Their surfaces were scarred by ancient impacts, but otherwise they seemed utterly still. No cracks, no plumes, no hints of the dynamic processes seen on moons elsewhere in the solar system. For planetary scientists and astronomers, this was a sobering discovery. Many had hoped to find evidence of hidden oceans or geological activity, signs that these distant worlds might be more than just frozen rocks. Instead, the data seemed to confirm their worst fears. Uranus and its moons were cold, dead, and unchanging. But now, decades later, a new discovery has overturned that view. Scientists have realized that the empty magnetosphere Voyager 2 observed was not a sign of lifelessness, but rather a temporary silence after a powerful space weather event, a cosmic calm after a storm, not evidence of dead moons. This revelation changes everything. It's now plausible, even likely, that Uranus's moons are active, perhaps even supplying plasma to the planet's magnetosphere, just like the energetic moons of Jupiter and Saturn. These moons could be hiding internal heat, driving processes beneath their icy shells. The possibility of subsurface oceans, vast, dark seas beneath the ice, is back on the table. If true, these hidden oceans could be among the most promising places to search for life beyond Earth, and they would make Uranus's moons far more dynamic than we ever imagined. Uranus is no longer a silent outlier, but a potential host of dynamic, intriguing worlds places where the story of our solar system is still being written, and where new mysteries are waiting to be uncovered. The true story of the Uranus system is only beginning to unfold, promising new discoveries and a fresh sense of wonder about these distant icy worlds. The idea that Uranus's moons could be geologically active reignites the search for hidden oceans. Across the solar system, icy moons with subsurface seas are prime candidates for life. If Uranus's moons are active, tidal heating could keep their interiors warm, just like Europa or Enceladus. Titania and Oberon now stand out as promising targets for ocean detection. Magnetic induction, detecting a moon's response to Uranus's magnetic field, could reveal these hidden seas. The 2024 study shows even during extreme storms, the major moons remain inside the magnetosphere, making detection possible. The path to discovering oceans at Uranus is clearer than ever. A new era of exploration is within reach. The revelations from Voyager's data make a return to Uranus essential. The 2023 Planetary Science Decadal Survey named a Uranus orbiter and probe as NASA's top priority. Our only visit gave us a misleading snapshot. We need long-term observation. A dedicated orbiter could monitor Uranus's seasons, magnetosphere, and moons in detail. Modern instruments could search for subsurface oceans and signs of activity on the moons. Such a mission would revolutionize our understanding of ice giants and inform studies of exoplanets. The mysteries of Uranus now call us back, promising discoveries that could reshape planetary science. The sideways planet is a new frontier, waiting to be explored. Voyager 2's journey is a testament to the enduring power of exploration. Decades-old data, re-examined with new tools, can rewrite our understanding of entire worlds. The value of a mission lies not just in immediate discoveries, but in the legacy of data for future generations. The Uranus paradox, born from a fleeting encounter, reminds us that a single snapshot can mislead. True understanding requires patience, curiosity, and the courage to question old assumptions. Voyager's saga inspires us to keep exploring, seeking not just answers, but better questions. The mystery of Uranus is deeper and more compelling than ever. What secrets still await in the darkness? The next generation of explorers will find out.